So this is going to be a lecture on we're going to be talking about solutions and more specifically how to make a solution. So this is going to give you some background information. These are notes that I have online, so you could always print these out and just follow through. We are going to be using terms called concentrated and dilute solutions. Now, I can't really give you an exact number for these to say which one is concentrated, which one is dilute, but you could generally say that if you have a large amount of solute for a given amount of solvent, that's going to be more concentrated, and dilute is going to be a small amount in a certain amount of solvent. So it's really going to be a comparison. So if I have a 6 molar versus a 0.1 molar, you are going to say that the 6 molar is concentrated compared to the 0.1 molar solution. So this is always going to be based off of molarity. And if you watch the previous videos on molarity, you will understand what big M means. So when we have a concentrated solution, we could easily take a 6 molar and put it in a new container and dilute it down to 0.1. So in order to make a dilution, we are always going to be going from a concentrated solution to a dilute solution. So we already know a unit called molarity, which is moles over liters, and we're going to use this expression here to do a dilution. So again, a dilution is exactly what it sounds like. I'm going to put in some more water and make it less concentrated. So if you think of something like a Gatorade or any kind of soda, if I were to put more water in it, it would taste diluted. It would not have as much flavor as it once did. So we're going to use a very common equation that chemists use. It's M1V1 is equal to M2V2. M1 is going to be the concentrated solution. So that's going to be the concentration of that. V1 is the amount needed of the concentrated solution. So generally speaking, that's going to be your X in this kind of problem. You have a new concentration dilute and how much you want to make. So in my example here, let's say my 6 molar is my concentrated and I want to bring it down to 0.1 molar. Well, let's say I have 2 classes of honors chemistry, so I need a total of, let's say, 500 milliliters. What I would be doing is essentially solving for that X. So it's multiplying these two, and again, since they are right next to each other, they're multiplying, and then I would be dividing. So let's try a practice problem together so you can kind of see how this goes. And then there are some other videos that you could find for this. It's a pretty common equation that a lot of chemists use. So if I have 500 mils of a 0.12 molar sodium chloride solution from a 5 molar stock solution. So again, stock solution is going to be your concentrated solution. It's a bigger value. So this is going to be your dilute solution. And it really doesn't matter where you set up your M1V1 versus M2V2. You just need the same thing on both sides. So since I want to make 500 mils of a 0.12, I'm going to put that as my M2V2. So I'm going to put that times 500 mils, and that's going to equal my stock solution, which is 5 molar, and then that's going to be my unknown X. So all I have to do is multiply this times this and then divide by 5. So X comes out to be 120 milliliters. Now, please note that as you have learned before, molarity is moles over liters. In this equation, you could use milliliters for your volume. It does not matter because whatever you start with is going to be what you end with. So in this case, I could have converted this to 0.5 liters, but I don't need to. This number is just going to be that same unit, okay? So again, the math is not the hard part. What you need to know is then what is 120 mils of? Well, that's 120 mils of the 5 molar. This is your concentrated 5 molar stock solution. So what are you going to do with that? All right, so I'm going to switch to another page here. You are going to be using different kinds of equipment, okay? This is what we call a volumetric pipette, and you're going to see that in a solutions lab as well. This is an instrument in a video that I want you to watch where you could actually put this in a container and you can have liquid in a container, and you could then essentially suck up, suck up literally, suck up the liquid into this volumetric pipette and then use it to dispense it into a new container. So you will see it in the video. If you click on a video called Making Solutions, you will see it in use. You are going to put that into what we call a volumetric flask. A volumetric flask is a container used to be an exact volume. Okay, so this is what chemists use all of the time if they want to make an exact volume of something. Now, what is key in both of these is there's a line on the neck of the pipette and on the neck of the volumetric flask. This is an exact volume. So let's say this is an exact volume of 500 mils. So when they made this container, they made it to be exactly 500 mils. This is very different from a beaker or even a flask. When we see lines on it, it's not an exact volume. So this is exactly when they made this piece of glass is going to be exactly 500 mils. So if I take this pipette and let's say it's 10 mils in terms of how it was made, if I suck up the liquid to that line, that's going to be exactly 10 mils. So if I go back to my problem here, I'm going to use a pipette and extract essentially 120 mils of that stock solution. And then I'm going to place it into a volumetric flask of about 500 mils. And then I'm not done at that point. So I'm taking the stock and putting it into the volumetric flask. And then I'm going to add water to the line. So the line is going to be exactly 500 mils. So back to here, I would take a volumetric pipette and suck up 120 mils of my solution. I would put it into my 500 mil volumetric flask, and then I would add water to that line. That would be how I would make that solution. So again, there's going to be a video you could watch somebody do this manually for you so you could see how this all fits together. But I will be asking you to do these types of calculations, and you will see my answer key talk about volumetric pipettes. So that's a volumetric pipette and a volumetric flask.